Well, good afternoon, everybody. Hopefully you can hear me, and some of the early people that have been waiting, I hope you enjoyed some of the videos that we had going there. We obviously threw in the Blower Brothers there for a little bit of entertainment. Goes back to the early days of 1980s when the Minneapolis blower door first came out, and so it was a way for everyone to just try and get an idea of how the products worked. So this afternoon, though, we're going to be talking about basic duct leakage testing. Just to fill you in, we will be hosting an advanced duct leakage testing webinar, and that will probably be taking place in January and hosted by Paul Morin. So hopefully as you see our email newsletters coming out over the next month. So testing 1, 2, 3. All right, sorry about that, folks. For some reason, the Adobe Connect decided to cut out. So hopefully everything is working now and the audio is working. So we'll get started with our basic duct leakage testing. As I was mentioning, in January, we'll be hosting an advanced duct leakage testing webinar hosted by Paul Morin. So you can take a look at our email newsletters with the announcement, and you should be able to see that again right after the start of the first of the year. So with that, we'll get started and continue on with basic duct leakage. So for housekeeping, we are broadcasting this by computer only. So if you can't hear, we'd ask you to check your computer settings for audio and volume of the speakers. Those are going to be important aspects to make sure that you're hearing all this. This webinar is being recorded and will be on the Energy Conservatory website in the near future for you to take a look at. You can ask a question at any time during the session. We'll probably review some of those at the end, but just go to the question and answer section of your screen, and we'll be able to take care of those. For those of you who are getting CEU credits or looking for CEU credits, the maximum is 1.25 CEUs through BPI. Those of you that have asked about ResNet, ResNet doesn't allow CEUs with webinars. For those of you with the BPI and you, in order to obtain that, be aware that the activity that you're doing on your computer will influence the amount of the CEU credits that you get. That's all determined by BPI, and they will provide that information to you, and hopefully the credits will be, or the CEUs will be credited to you very soon after the completion of this webinar, probably in the next 1 to 2 weeks. For those of you who have not provided your BPI number, make sure you send a message into editor@energyconservatory.com and include your full name, company, and your BPI number. We don't need your password, so just your name, company, and BPI number. That's all that's necessary to get that included. We will be showing you how to set up TEC equipment. Most of the information that can be used in this webinar can be used regardless of who the manufacturer of the equipment is, but we're going to be showing you how to do that with the Energy Conservatory equipment. And we thank you for your time today. We know your time is valuable, so hopefully this will be useful for you. First off, just to make sure that everyone's aware, the Energy Conservatory, our mission is to make buildings more energy efficient through the development and manufacture of diagnostic tools such as the Minneapolis Duct Blaster and the Minneapolis Blower Door. We also pride ourselves on the ability to provide you with the most comprehensive and extensive technical support, whether it's on the Duct Blaster, the Blower Door, or any of the equipment that we manufacture, including all the software that we work with. So our learning objectives today, a little bit different than what we had. I reshuffled them a little bit. We're going to learn about the current and future codes as they relate to duct leakage. We're going to learn how to perform a number of tests to measure duct leakage and we're going to learn what the results mean and the effects of duct leakage in a house. And with that, our agenda, we're going to cover a little bit of the IRC and IECC code status and requirements. So that's the International Residential Code and the International Energy Conservation Code. We're going to talk about DET and IDL. These are two ways of becoming a verified tester in various states and jurisdictions. We'll talk about the duct testing itself, the types of testing and the procedures, and what the numbers mean. So first off, the IRC and IECC. So the IRC addresses all topics related to residential construction, and that includes structural, plumbing, electrical, mechanical, everything related to a house. It allows a builder to carry only one code book, and Chapter 11 in IRC covers energy efficiency. So as the IECC, which is energy only, as that gets updated, that gets incorporated back into the IRC. The IECC itself, though, also addresses both residential and commercial energy conservation efforts. The IRC has incorporated the residential energy provisions of the IECC. So these are the two main standards that are the code values that we're going to be looking at, the 2009 and the 2012 version. The 2012 version here, section 402, and in the IRC it's section N1102. Now, part of what we're going to get and understand about which areas are required to have which code compliance values, we've been using this particular website, the Building Codes Assistance Project. Also, they have this energy code ocean.org, which is a way for you to take a quick look and see what your jurisdiction or your state has on tap for its standards. So here is the latest edition or the latest map, which summarizes the code level status for each of the countries, each of the states. So you'll notice that this dark blue one represents the 2012 IECC or equivalent. The next lighter blue is 2009. The light blue is 2006, and the gray means that there really is no provision for a code other than 2006, or there's none at all. And you can also see that this map identifies a couple of states where the codes are changing. So for example, here in Minnesota and Montana, those codes are in the process, they've been approved and are in the process of being activated. As we look at this map, one of the things that we've learned is that in reality, there's 17 states that have not adopted the IECC 2009 as part of the code, which is contrary to the fact that every state accepted the American Recovery and Reinvestment Act funds. As part of using those funds, each state was required to bring their energy code up to the 2009 level. And yet here we see that there are still 17 states that still have not adopted it. The other part of this code and energy code compliance is that states are free to adopt the I-codes by reference, meaning for the state of Minnesota, they can say, we adopt the IRC 2012 in its entirety. They can also say, we want the IECC 2009, but we're making an amendment to change this aspect or that aspect. So the state is free to do whatever they want with the individual code. The state of Georgia's amendments to the IECC will be discussed as an example as we go further. Also, individual jurisdictions within a state are taking independent action to whatever the state is doing. And in some cases, it's to be stricter, and in some cases, to be less strict. One of the things that we found out is that in looking at the state of Colorado, they're listed as a state that has nothing higher than the 2006 code. Well, when you go through that, further explanation is that the state is developing a statewide code, but El Paso County, which is the Colorado Springs area of Colorado, their building official has adopted portions of the IECC 2009 so that all the builders understand that they have to build their houses better than just the standard state code. Also, while I was in California last week at a trade show, I found out that there's a particular county in California that seems to be exempting all duct testing. The building code official apparently isn't all that familiar with the reasons for duct testing. Also, much of this has to do with what do the code officials understand about the codes themselves? Are they do they understand what the code means? Who does the testing? What happens to the test results? No matter what, one of the things that we always recommend is that you check with your local jurisdiction regarding those requirements. So even though the state may have one particular set of code requirements, they could be higher or could be less depending on your individual code official. Another amendment that Pennsylvania did is something that's entirely different. They adopted an ASHRAE 152 test, which is the method of testing for determining the design and seasonal efficiencies of residential thermal distribution systems. This is in general is a laboratory test, but one of the appendix parts of the test talks about how to actually do a duct leakage test. It's not necessarily one that we would recommend, but is certainly something that's out there that people are using. To go back to the state of Georgia, in 2009, they adopted the IECC 2009 into their state building codes. And they were probably one of the first states to really embrace this and make it happen. And in order to do that, one of the things that they tried to understand is that duct leakage is not something that you can see, and it has to be tested. And in order to do that, we need people that actually understand how to test and what the numbers mean so that they can provide guidance back to either the HVAC contractor or to the builder. Now, this is both duct and envelope. And today we're talking about just duct leakage, but a lot of this stuff is going together where there's a requirement for duct leakage testing as well as envelope testing. So in Georgia, the people that are allowed to do the testing are people who are already HERS raters through ResNet. They're home performance with Energy Star contractors, meaning they're on the DOE website. People who have the BPI building analyst, or they complete a certified DET course. And you can see down here at the bottom, the DET course is something that is not as intensive a training program as the BPI building analyst, because there's not as many things that you need to concern yourselves with when you're dealing with the DET course. Now, this course was developed by an organization called Southface out of Atlanta, Georgia. They have been putting together training programs for a lot of different groups. A lot of it started with the weatherization, but they also have their own standard for earthcraft and things like that. They also do BPI testing, and they worked with the state of Georgia to develop this duct and envelope testing verification training program. The training program itself, the curriculum, has been available the curriculum has been available to a lot of other states to be able to use it because it's really a good model for what the DET type of testing can do for both the building officials as well as the contractors. One of those states that adopted the South Face program and embraced it and turned it into their own was the state of Illinois. And in January of 2013, they implemented the 2012 Illinois Energy Conservation Code, not the international one, but the Illinois one. And they did that with a couple of changes to it. So they've modified the actual values for each of the IECC requirements. But one of the things that is happening with all of these states is that they are slowly getting their builders and contractors to understand what's going on. Certainly getting people to at least start looking at the codes and the fact that there's going to be a test, that there's going to be some checklists that need to be filled out and things like that. And they're using the process of developing these codes in a very slow manner, where they first adopt a code to say, this is one option that you're able to do a test or do a checklist. The next time they adopt the code, they will get rid of the checklist and say, well, you have to test, but here's a rather lenient number. And then the next time it comes out, the test is, you have to test, but the values are going to be a lot tighter. So Illinois is one of those where they've kind of gone all the way in working on the energy efficiency code and putting in some strict requirements throughout the state. One of the states that recently is doing some things with duct and envelope is the state of Louisiana. Now, their requirement is that it has to be a nationally recognized certification program, which would mean BPI or HERS. The DET is not a nationally recognized program. It's something that was developed by South Face to work with an individual state. It's not a nationally recognized program. So BPI has now developed the IDL, or Infiltration and Duct Leakage certification. This is brand new. Because it's developed by BPI, it's considered a nationally recognized program. There is no specific training program involved with IDL, but there is a proctored test so that an individual who wants to receive an IDL certification has to take the equipment, make arrangements with someone who's going to oversee their test, and then perform the test completely to the satisfaction of the proctor. Then that gets entered or sent back to BPI for them to receive their certification. So it's a new program. It just came out at the beginning of November. And so we're waiting to see some more information coming from BPI and how that's being rolled out. Some other things that we've learned. The adoption to the code is slow, as I was mentioning. But this is going to be kind of a relentless process where all the codes are going to be updated over time. The states may vary from one to the next, and they're going to change over time, but they will take place. So what we're seeing is that more education is needed throughout the entire system. The State Energy Office needs to understand what these new codes mean. The code developers, both at IECC and on the state level, more education there, because one of the things that we're finding is that the code is being written, but a lot of the language is open to interpretation, and you would need to go back or request a comment by the code counsel for them to provide you with clarifications on what a certain part or certain language is of the IECC as it might relate to that particular state or jurisdiction. The individual code officials, this is something that we're seeing kind of all over the country, where the code officials are trying to do their best job possible, but they're still trying to understand, what do I need to, what am I looking for? What kind of paperwork has to come in before the test? Does someone need to be on site, such as having the inspector there? Does he need to be, or he or she need to be on site when the test is performed? Can the contractor send in that information? And then what happens to that paperwork afterwards when the test is done? Does that still go and close out the building permit? So there's a lot of things going on with the code officials and inspectors. Builders and contractors certainly are people who are learning about what needs to be done for the code so that they can continue to provide all of the good things to their customers. And homeowners need to be aware as well. One of the things that we're seeing is that in the state of California under Title 24, anybody that does any kind of work on their HVAC system requires a duct leakage test and to have the duct leaks sealed to a specific value. This can add a significant dollar amount to someone who's just had a broken compressor. But the reality is that this will help the individual homeowner. They'll have someone who's testing it and making sure that the ductwork is sealed and it's working properly, and they'll have a much more energy efficient, comfortable home. So through this whole thing, throughout the system, we're seeing that more education is really needed to ensure that this is something that's going to be continue to move forward. Because right now, for example, here in Minnesota, gasoline prices are at a considerable low. So gasoline prices aren't going to be driving this thing. It's the code and the comfort values that are going to be taking place. So what is it that we're actually talking about with the code, and what does it mean? So under the 2009 IECC, duct tightness tests shall be verified. Verified meaning it's going to be pressurized and tested. So post-construction, there's two methods: leakage to the outdoors or total leakage. When there's leakage to the outdoors, this value is 8 CFM per 100 square feet of conditioned space. Or if it's just total leakage, and we'll get into this a little bit, it is 12 CFM per 100 square feet of conditioned floor space. All the register boots shall be taped or otherwise sealed during the test. Also under the IECC, supply ducts in the attic shall be insulated to a minimum of R8. All the other ducts shall be insulated to a minimum of R6. The exception, and this is going to be important as we move further on this on the discussion, is ducts or portions thereof located completely inside the thermal envelope. This is 2009 wording. So any ductwork that's inside the house, so for example here in the upper Midwest, new homes are constructed with the air handler in the basement, and there are a number of supplies and returns, but no one now is allowed to put them in an outside wall. So they're all internal, and they don't break any of the thermal planes to the outside. So under the 2009 code, they would be exempt from any form of duct leakage testing. Sealing. All ducts, air handlers, filter boxes, and building cavities used as ducts shall be sealed. And I'll show you some examples of sealing and what some good stuff actually really means. Now here's a difference between the 2009 code and the 2012 code. So you can see that there are subtle differences, but in this particular case, 2009 403.2.2 sealing. All ducts, air handlers, filter boxes, and building cavities used as ducts shall be sealed. Under the 2012, the wording is ducts, air handlers, and filter boxes shall be sealed. And under the category of building cavities, here, building cavities shall not be used for supply ducts. Under 2012, building framing cavities shall not be used as ducts or plenum at all. So there's subtle changes, but will have dramatic effects on how the ductwork is constructed, how it moves through the house, and then how it has to get tested. So when we're talking about duct leakage, here's a couple of perfect examples where we have a plenum or a branch, and there's a takeoff attached to that. In the process of putting the takeoff into the piece of flat sheet metal is that there are a number of tabs or ears, and when it's placed up against the hole in the plenum, the contractor reaches inside and basically presses down each one of those tabs. Well, invariably, there will be an occasion where there's a 12-foot run of ductwork, but the contractor only has 11.5 feet of duct. And so they will tend to pull on it, and that takeoff, because it's not a very strong mechanical connector, tends to loosen up. So what you see is that these holes along the edges, and in the case on the right-hand one, is nearly completely off. So something that we see quite often. This contractor, I think, probably should get an A for effort, but certainly an F for execution. It's pretty clear that he was trying to fit the ductwork through the cavity on the left-hand side, but the plumbing pipe on top just wouldn't allow him to make the connection of the ductwork on the right-hand side. So it's close, but not really good enough. So what does it mean when you have duct leakage? Now, here's a case where this is a home that had conditioned, all the ductwork is inside the conditioned space, but was leaking to the rim joist on the outside. And over time, that mixture of air with moisture against the surface caused mold on the building material of the house. So this, while normally leakage in conditioned spaces isn't that big of a deal, here's an instance where this caused some really serious damage to the house. Now here's an instance where certainly here in the upper Midwest and the Northeast, if there's any leakage to the outside, in a cold environment and you've got a heated supply that's leaking, here's an instance where frost started to gather on the attic structure of the house. So here, leakage to the outside can be a really serious problem that over time this will melt, go through the structure of the house, and cause other damage elsewhere. Here's a simple illustration on what we're talking about with all those various duct leakage interactions and where the leakage can pull from on a return and spread out on a supply. One of the things that we're also really concerned about is this interior cavity leakage. So for example, here is a wall cavity that has a leak in it, which could very well be coming from the attic, and because it's not sealed well either on top or on the bottom, is actually being drawn into the air handler. So what are we talking about when we're sealing? Here's some terrific examples of putting mastic on a duct to ensure that everything is sealed. Now this guy probably went a little bit wild because I'm not sure that they could get the electrostatic filter out of there, because that looks like that might have actually been sealed in place as well. But you get the idea that this is something they're doing. The process of adding mastic to your connections can be as simple as putting just the excuse me, just putting the mastic onto the joint, or in this case, adding some fiber tape to help with the mechanical connection. Here is an instance where these takeoffs, this takeoff is never going to come loose from this plenum box here, because they've done a really nice job of mastic around the flex duct and that union to the duct board, and as well as they've sealed all the joints of the duct board. Here's a case where the mastic is placed onto the boot connection. This has a nice pan on it for when the drywaller comes in, and he's able to just place that right over that, and so there won't be any leakage around the drywall into the house. Here's an interior return. You can see that each of the joints is sealed off. There's a little bit of mastic on the inside of the takeoff that's directly in front of you, and you can see mastic that's also down at the bottom. Now here's a case where the ductwork is, and this picture is a little unclear whether it's the inside or the outside, because when you look at the in between the roof rafters, you'll see shiny material. So they may have put some insulated board on top of the rafters, and therefore this is inside. More commonly, what you'll see is something like this, where they will foam the attic wall, attic deck, and roof deck, and just leave the ductwork suspended inside the attic. But now the attic is conditioned space, so whether there's leakage here or not, it's certainly not an energy penalty. Leakage there could be a problem for air distribution and pressure balances throughout the house, but in this particular case, it's not an energy penalty. So when we're talking about tests, what types of tests are there? How do we set up for those tests? We're going to talk about the leakage results and calibration. Probably the most common is a total duct leakage test. The total duct leakage test is certainly required in 2009 and 2012 IECCs. You can pressurize the ductwork or depressurize the ductwork. There's a couple of techniques that are required when you're doing a depressurization, but most people will do a pressurization because they want to push any possible contaminants out of the system rather than bringing them into the home. The duct blaster or duct leakage tester can be connected to the central return or the air handler. We're measuring the airflow in CFM needed to pressurize the ductworks to 25 pascals. And we're measuring all duct leakage, no matter where they are, whether it's the air handler, the plenum, trunk lines, takeoffs, boots, everything. A variation on this is the duct leakage to outside. Now, it's required in 2009, but it's not allowed in 2012. And the reason it's not allowed in 2012 is because they want they want total duct leakage to be as small as possible. And again, you can pressurize or depressurize the ductwork. The duct blaster is connected to the central return or air handler. The blower door is operating to pressurize the house if we're pressurizing the ductwork, pressurizing the house to 25 pascals. Now in this case, we're measuring the airflow in cubic feet per minute needed to equalize the pressure in the ductworks to obtain a zero pressure differential value. Now this only measures the duct leaks that are outside the building envelope, or I should say the thermal envelope. So attics, crawl spaces, and garages. Now for all of these, one of the things that we want to make sure of is that all of the, when we're doing a rough-in test or whether it's a regular test, is that when the registers are applied, we are putting mastic or a duct sealing, duct register tape. We're putting it over the opening of the register. Now we're not dragging the tape along the side of the wall, because one of the things that we're trying to do is stop the what would be called intentional leakage. The intentional leakage is the opening of the register. The unintentional leakage is when the register isn't quite sealed to the floor or wall or ceiling. That represents, that can represent a significant amount of duct leakage. There was a study done by Tennessee Tech a few years ago where they had identified that the average leak, this is just an average leak out of a number of homes, that the average leakage in the area behind the register but in front of the boot, so this space along the side of the register, can be 10 to 15 CFM. Now normally we might say, well, what's 10 or 15 CFM? That's hardly anything. But if you've got 10 registers leaking 15 CFM, you're at 150 CFM of leaks so far. And you haven't even looked at the ductwork to see how much that's leaking. So we want to make sure that when you're applying the register tape that you're using it there. Now in some cases, some people are taking the register off and putting in some closed cell foam into the duct. So as long as it's identified that that's how you're testing it and it's okay with a building official, then that can still be, that can be an okay test. We're just telling you that in most cases you want to test with just putting tape over the register. So in this case, we're doing a rough-in where the air handler is installed. Total leakage is less than 6 CFM. For this particular requirement, we're testing at a differential of 25 pascals or 1/10 of an inch of water column. And all registers and boots are taped. When the air handler is not installed, you're allowed to go to 4 CFM, which is a tighter test, but you're also assuming that the air handler itself is going to be leaking, which it does. So again, types of duct leakage test, the total duct leakage, we're measuring all leaks throughout the system, pressurizing or depressurizing. The duct blaster is connected to the central return or air handler, and we're measuring 25 pascals and the airflow required to maintain that 25 pascals. Duct leakage to outside, we're only measuring the leakage that's going to the outside because we're running a blower door test as well that neutralizes the pressure differential of all the ductwork that's inside. And again, we're running a duct blaster connected to the central return or the air handler, and the blower door is pressurizing the house, and we're measuring airflow in CFM, but we're trying to reach 0 pascals, and we'll show you the setup for these two different tests. So it's a good idea again to review what is the conditioned space versus the enclosure. So for example, in the upper left, you can see the attic roof deck. That roof deck continues on, but they've made essentially a knee wall so that the attic insulation is going along the vertical portion of the wall and then makes a turn for the floor area, ceiling area on the left-hand side. The area where it's listed as attic, that's unconditioned space. So we want to try and get ductwork out of that location for energy savings. So here's the setup for a total leakage test using pressurization. So we're depicting what's happening and how you set up the house. So we have the duct blaster fan connected to the air handler system. You can see that we're depicting some leaks into the crawl space underneath and the attic on top. Now, anytime that we're measuring we're measuring in the ductwork, placing the fan and turning it on. We're measuring at 25 pascals. So when we get to 25 pascals, the amount of airflow that's going in is then showing the amount of air required to maintain that, and that's our duct leakage. So here's some examples of the setup. Here's a case in the lower left, picture of the duct blaster fan being connected directly to the air handler, whereas on the right-hand side they're using ductwork, and then the upper right is just connecting it to a large return. Total leakage test, here we have our 3 rings. We now have ring 4, which will bring the test down to 3 to 5 CFM. That's a really, really tight piece of ductwork, but some guys are actually trying to get there. We want to make sure that the air handler is turned off, that the registers are covered. It doesn't have to be a duct mask. It can be painter's tape, cardboard with painter's tape, anything that's going to be used to seal this off. Just to make sure everybody understands, though, we want to make sure that we're sealing the just the register itself, not the register to the wall. We want to turn off all the exhaust fans and dryers. We want to remove the air filter from the duct system. And we're going to open a door just so that the pressure differences in the house are eliminated. And we want to open access doors from the unconditioned space to the spaces containing ducts to the outside. We want to select a location to take the pressure measurement. This can be done either at the supply plenum or in an adjacent register. Not the same register that you hooked the duct blaster to, but one on the next, could be the next branch to be able to do that test. In zone systems, we want to make sure that you have all of the dampers open. Your test is going to be really kind of wacky if you haven't done that. So you have to do a manual override to make sure that all the zone values, valves are open. We're connecting the tubing to the DG700. You'll see that the green hose is connected to channel A, and that's going to the ductwork, and channel B is going to the fan. So here we're going to put the DG700 in pressure flow at 25 mode. This is just a way for you to get to the test quickly without, you don't have to be at exactly 25, you want to get close. And the value that's going to be shown on channel B, whether you're at 23 or 24 or 25, it's going to be calculated as if it's 25. And that's going to be very, very, very close. If you're in a very leaky duct system, you got to make sure that you have at least 5 pascals of pressure. Otherwise, the no flow value will be displayed on your gauge. Now here's the setup for leakage to the outside test. And you can see that we still have our duct blaster fan hooked up to the air handler, but now we have a blower door fan that's connected to the house. Our window is closed, and the blower door fan is going to be blowing at 25 pascals. Now we're using 25 pascals because that's the typical value for duct testing. And when we fire up the duct blaster fan, we're going to be putting air in enough so that when we measure the difference across the ductwork inside the house, that there's going to be no pressure differential. In other words, zero. So when possible, unconditioned zones containing ducts should be open to the outside. Windows and doors to the outside must be closed. We're going to prepare the house for a blower door test, even though we're not doing a test, where we need to make sure that the water heater's on pilot, turn off the heating and cooling system. We're still sealing off the registers just like we did in a total duct leakage test. And the fan setup for the duct blaster is the same as in a total duct leakage test. We're now installing a blower door fan to pressurize the house. We're going to start the DG700 gauge on the blower door, and we're going to go to the cruise mode and set that to 25 pascals. My picture here shows 50, but we want to make sure that that's 25 pascals. And then we start the fan on the blower door to make sure that we're at 25 pascals. Now our setup for the gauge for the duct blaster is exactly the same as before. Channel A is the duct leakage, and channel B is the fan. But in this particular case, what we want to do is we want to put the gauge in pressure flow mode, not the at 25. This is a very, very common question that comes to us, is that they're trying to read the value at 25 pascals and the numbers just don't make sense. So we want to make sure it's in pressure flow only. And we're going to turn the blower door fan on so that we're adjusting channel A on the duct blaster connected gauge to read 0. And when that's the case, you'll see your leakage, 107 in this particular case, on the right-hand side, channel B. So some of the pros and cons of the different types of tests. We have total leakage tests. The pros are going to be done at rough-in, shorter setup time, less equipment. Your leakage values are going to be a little bit larger. Can be harder to meet Energy Star requirements with larger leakage numbers. And if testing at rough-in, often have to accept the penalty for missing register grills and missing air handler. The outside leakage test, the pros are is that you're going to get a smaller value, but that's obviously because hopefully the leakage to the outside is going to be smaller. It's easier to meet Energy Star requirements. There's a longer setup time, more equipment, and it cannot be done until the building envelope is completed. So that may be, in some cases, certainly for new construction, that can be a concern. Tips and troubleshooting. When performing a leakage to the outside test, perform a total duct leakage test first. So why would you do that? One is that it gives you the maximum amount of leakage that's in the ductwork. Both total leakage, meaning inside and outside, all of it. So when you're doing a duct leakage to outside test, the number can never be bigger than the total leakage. It's always going to be a fraction or a subset. When you're doing an outside test, the number is always going to be smaller than the total leakage test. And so, for example, if you've accidentally put the gauge on pressure flow at 25 mode, by doing the total leakage test first, it helps you identify that the numbers aren't making sense, that it has to be a smaller number than the total leakage test. It's always something that I always recommend. So how much duct leakage is actually acceptable? So what's that mean? So what do our leakage results come down to? So if we use California as an example, all the ductwork is usually outside the building envelope. And since it's already outside the building envelope, a total duct leakage test is usually what's performed. It's rarely a duct leakage to outside, because again, all the ducts outside, why do I need to do both tests? So under Title 24, the total duct leakage cannot exceed 15% of the rated flow of the air handler, or the reduction of total leakage has to be at least 60%. Now, certainly this would argue that you'd have to have a test beforehand in order to be able to come up with a calculation of what the total reduction is later on. Now for Energy Star, if you want to go to a slightly different standard, it's 6 CFM per 100 square feet of floor area. So what do these numbers actually mean? So if we take our California house, the house has a 2.5 ton system, and using a formula of 400 CFM per ton, that equals 1,000 CFM. Now sometimes, just a comment on this 400 CFM, sometimes the local jurisdiction or the state will say that we're going to allow 350 CFM per ton. So you have to adjust that calculation accordingly. So with the retrofit at 15%, we're only allowed a total, in this particular case, with a 2.5 ton system, of 150 CFM of duct leakage. Under new construction, and we look at the house as being 1,000 square feet, under Energy Star and 6%, that equals 60 CFM of leakage to the outside. These are seriously tight houses. Something to be, every contractor, we would hope, would get to, and that's something that we want to encourage people to do. So let's do a little bit of understanding what the impacts of that are. So outside duct leakage test results are 300 CFM at 25 on a 2.5 ton system. If we assume that the leaks are split equally between the supply and return side, the result actually is a 22.5% annual energy penalty. A 12 SEER system is now actually only operating at 9.3. And if it's a furnace operation, your 80% furnace is now only operating at a 62% efficiency. So these are direct results of what leakage can mean. This is all outside of the fact that the home may not be comfortable to the occupants. Duct leakage to the outside is a direct energy penalty for heating and cooling. So in any parts of the country where ductwork is outside, this is becoming a really important issue. It always has been important, but now it's being directed to the energy side. The part of having people look at their monthly energy bills may not be the best indicator or best way to sell a job to seal a ductwork, but certainly the house is going to be more comfortable. Any duct leakage that's outside the building envelope creates an energy penalty as well as air quality problems. Duct leakage to the inside is not a large energy penalty, but can contribute to the problems related to the delivery of air, comfort issues, and other problems related to pressurization or depressurization of the house. Could have to do with homes in the Midwest, certainly, that have natural draft water heaters. If the duct work isn't sealed properly and you wind up creating a negative pressure environment in the mechanical room, then the furnace will wind up backdrafting, and we certainly don't want that because now it's a clear safety issue. And be aware that sealing all ductwork can cause other problems related to the air handler or combustion safety. So for example, there's a story of one fellow that got the duct sealing religion, if you will, and went out and started sealing every piece of ductwork in every house he worked on. The problem was that he didn't identify the fact that when he sealed all the return leaks, the returns became undersized. And so when the homeowner decided to turn on the air conditioner, there wasn't enough air to actually move through the system to make it work right. So the cooling coil of the air conditioner wound up freezing and creating an ice block in the air handler. And so there was no air going through. So just to make sure that people are aware that, we want to make sure that a system is constructed properly, and that when you're looking at the duct leakage, if it's on the return side, that you have enough makeup air coming into the system to offset what you're going to be sealing. So moving on from just the testing itself, one of the things that a lot of people are doing is adding a field calibration plate to their systems. Those of you who might be ResNet are very familiar with the fact that this is indicated in their calibration procedures to add this plate to the end of the flex duct, and it's designed to simulate a duct leakage test with a leakage of 106 CFM. So you want to make sure that you hook this up and test it occasionally, and that will give you an integrity test essentially for the gauge and fan and hoses, in fact. So then what about finding the leaks? Here's a perfect example of fogger being used and added to the ductwork. One cautionary note is that you want to put in just a little bit of fog into the ductwork. Otherwise, you get kind of this hazy image where nobody can actually see where the duct leakage is, because the whole room is just filled with smoke. So you only want to use just a little bit of smoke, and make sure that you're able to see that as it's moving through the system. Certainly another way, and in this particular instance, one of the how this leak got found was that this is in a crawl space of a North Carolina house, and there was water dripping from the ductwork. And this is, you can see that there's insulation in the ductwork, but there was water physically dropping down. So one of the ways to find the leak is to look to see what problems are manifesting themselves for the homeowner. Another way to do some duct investigations is to use an infrared camera. But you have to use an infrared camera very carefully when you do this. In this particular instance, here's a case where we can see that in this attic, that black being cold and white being hot, that we're able to easily identify leaks coming through from buried ductwork. Now the picture on the left-hand side, since it's a much smaller and very defined area, this could very well be an open light outlet in a bedroom or something like that, where it's very easily defined. It's a small area. But the area on the right-hand side is buried ductwork, and you're able to get a better feel for that and see that more. And so when you finally dig through all of the insulation, you're able to see that that's where it's leaking from. Now, some other types of diagnostics, and again, some of this is going to be covered when Paul does his session on advanced duct leakage testing in January. There is a way to do duct leakage diagnostics using a blower door. And one of those is that you use a pressure pan. So the pressure, you pressurize the house to 50 pascals, and then you take the pressure pan and you place that over the register. Now, if there is no leakage to the outside, the pressure value that you read on your gauge would be 0. If, on the other hand, that there is a leak there, you might start to see numbers in the vicinity of 3, 4, 5, 10 pascals, which would then tell you that that portion of the ductwork where that register is located, that portion of the ductwork is leaking to the outside. Now, this is strictly a qualitative test and is used to help find some of the dominant leaks of the house. It's not going to be acceptable under the code restrictions or the code requirements where they want to know, I want to know how much leakage there is in CFM. This is just a way to help investigate where some of those leaks might be. Another test using the blower door for duct leakage is what's called blower door subtraction. In this case, what we want to do is test the house for leakage. And you're setting up the house just as if you were doing an air infiltration or an air leakage test, and you record that number. You would then seal all the registers as if you were doing a duct leakage test with a duct blaster, and then test the house again. And you compare the two results from the sealed and unsealed registers. The result should be duct leakage to the outside. It's a test that we would recommend that you do cautiously, but is being allowed in some jurisdictions as the way to give you that that piece of information on how much leakage there is to the outside. Certainly, tools that you would use for finding leaks, certainly the blower door and infrared scanners, as well as smoke pencils and theatrical foggers. We talked a little bit about the foggers already. Here's a case where just taking a simple fogger or a smoke pencil, and while the house is being pressurized, here's a case where going to different locations and hitting the puffer, you can see that the air is moving through the wall cavity and other areas. So that's an indication that you've got duct leakage to the outside. Moving on to some other pieces of information. So fan calibration. Fans maintain their calibration usually unless there's some sort of physical damage that occurs. And these conditions are easily detected, and you should look at your fan on a regular basis and see what might be occurring. Two things affect the calibration of a fan, whether it's a blower door or a duct blaster fan, and that is the position of the fan and sensor in relationship to the housing, and whether the flow sensor has a leak in it. Now, most of the time, the duct blaster rarely has a flow sensor leak because it's made out of a stainless steel tube. But the leaks can occur in the tubing that you connect to your fan and to the gauge. So if there's any leak in the tubing, that will affect your number. Certainly, a damaged fan housing that where the fan housing starts to creep into the area where the flow is moving. If you've taken a chip out of the outside edge of the duct blaster, that's really not something to worry about. But if you start getting a hole where the radius of the inside of the duct blaster fan starts to move into the fan itself, that can cause an issue with calibration. So here again, we're trying to identify where this is, where do you do this? So the process is you take a straight edge across the outside housing, and then you measure into the fan. Now, in the case of the duct blaster, we're measuring that location, and that's usually in a range of 7/16 to 9/16. You want a 1/2 inch position. And you can go in and adjust the location of the motor to make sure that it's in the right location. If you do have bent motor mounts or damaged props, you really need to send that in to us, and we can fix those and get your system running back again. Now the gauge is a little bit different. The gauge has a recommended calibration of every 2 years. This is something that's really only performed at the Energy Conservatory. You can perform a calibration check once you've received back a freshly calibrated gauge, either one of yours or a friend's, and compare the gauges. But a true calibration is really done at the factory. The cost of that is $100 and is usually completed in just 3 or 4 days once we have it. The other calibration checks are located in the blower door or duct blaster manual, where to look, what to look for, and how to do those checks. And then if you have an older gauge that doesn't have cruise, that's something that we can add, and that's an additional $50. So some other useful information is certainly go to our website for all of the latest news, all the manuals and things like that. We do have some articles on air sealing, duct leakage diagnostics. We do have some of our newsletters that you can go to. Certainly all of our manuals and guides are online. There are video quick guides for the blower door and duct blaster. We will be working on a video to show you the duct leakage to the outside. That's something we don't have right now, but that's something we want to add so you can see that a little bit more easily. We have links to other sites, and we certainly encourage you to download the latest version of software to make sure that you're really using the latest and greatest. So with that, that completes the formal presentation. But I think I'm going to go back to some of these questions that you guys have sent in. Questions on the slides. The slides will be available in a PDF format, and we can have those available for you to download to you. So those can be available. And again, sometime within the next 2 weeks, we'll have that taken care of for you. Let's see. One of the questions is, would you also want to seal the inner jacket of the flex duct before you install mastic on the outer insulation of the jacket? And certainly, yes, that's something we want to make sure of. That the tie strap tightening tool, a lot of guys will try and tighten it by hand, but certainly you want to do a mechanical way to tighten that as much as possible. Once you've gotten that tight, then just doing mastic to the outside is all that's really necessary. Another question is, even if the roof deck is installed, shouldn't you also want to seal the ducts? Well, certainly that is what we're trying to do. You do want to seal the ductwork, and in the 2012 version of IACC, it doesn't really matter where the leakage is. It has to be sealed. So we want to make sure that it's sealed, whether it's in the attic, whether it's in the house, crawl space, anywhere. So those are, you still want to have all the ductwork sealed. Will there be links page to some of the code sites? We have some of that, but I think that's a good idea, and I think we'll work to add some more of those. But certainly, I would recommend going to the BCAP website. that's going to be a location that gives you some easy access to all the states. And certainly we'd want you to check with your particular state energy office or code office and find out what is the latest that's going on. So we can put in some of the links to the international and national standards, but you're still going to need to go back to your state to get some of the more nitty-gritty details. Question is, do you recommend this for retrofit, such as weatherization, or is new construction for duct blaster? Not really sure what that question really is. Under some weatherization programs around the country, certainly those that are in the south and west, duct leakage is important, and that's part of the weatherization process. So those are something that's being taken care of in weatherization, where they already know that that's an issue. Let's see, question here. Here's one. I only seal over the register, not to the wall, but performing QA on raters has created quite the pushback on this. Their argument is that the majority of the air is getting to the desired location. What would be your response? Well, we just referred to Resonant Chapter 8 as that, that tells you how to apply the, how to seal off the register, and it does leave it open to a little bit of interpretation, but the idea here is that we're always trying to seal off the intentional leaks. When there is an unintentional leak, those are the things we want to stop and seal. So if you go to the wall, then you're sealing off the unintentional leak too. So you're actually getting a bonus for the sealing process. So that's something that we want to avoid. Also, one of the things that happens with, certainly with the duct mask tape, is that it can be pretty aggressive. When you connect it and tape it to the wall, there's a chance that you could, in order to get that perfect seal, you will be peeling the paint off of that wall. We also recommend that when you're using this, if the homeowner has painted their register, then you need to take that register off, or tell the homeowner that when you peel the tape off, there's a good chance that the paint is going to come off of the register. So we want to make sure of those kinds of things. Let's see, what else do we have? How would one know if they have enough system return air if all the ducts are sealed? So after the technician is done sealing the ducts with mastics, he would turn on the air handler and measure the external static pressure. This goes back to a traditional HVAC technician test. And you want to make sure that they're, when all of that extra ductwork gets sealed, the external static pressure is going to start to climb. And when the external static pressure climbs, that means there's a reduction in airflow. So you'll see that. Another way to find out is by taking the one of our other devices, a TrueFlow air handler flow meter, and placing that inside the air handler and making sure that you have enough airflow through the system to make sure that you're working properly. Because now once you've sealed all the ductwork, now you have to provide some sort of makeup air or additional outlets. So you want to make sure that that's done thoughtfully and carefully. And can you use the DG700 to check static pressure? Absolutely. The DG700 is an electronic manometer, and so anything that you would want to measure any kind of differential pressure, static pressure being the pressure difference between inside the duct and outside the duct, the DG700 is a perfectly good tool for that. Question on the DG700, what's the difference between the Duct Blaster A and DBA and DBB. DBA is the Duct Blaster Series A, which is a white fan. That was our first fan that we developed in the mid-90s. The Series B, the black fan, followed soon afterwards. There aren't very many A fans out there, but when we developed the DG700, there still were a number of those A white fans still out there. So that's what that is. So when you're using it and you have the black fan, and most everybody does, you want to make sure it's on DBB. Let's see, question on, here's a lengthy question on external static pressure. And I think that's going to have to, wait. Let's see. Yeah, let's see. So static pressure test to the outside when using a DG700. The static pressure test is basically, if you're doing just a straight duct static pressure, all you would need to do is place the, drill a hole, place the right angle probe for the right angle probe that has a magnet on it. That's our static pressure measurement tip. Place that in the ductwork and take the hose, connect it to the static pressure tip, and connect it back to your gauge. And you want to put it on just channel A input, and your reference is where you're standing, which is the outside or the outside environment. So when you turn the air handler on, now you have static pressure to the outside, which is static pressure relative to where you're standing, inside the ductwork versus outside the duct. Now, if the question is when you're measuring external static pressure, there's a procedure and a guideline to follow for that, where you're going to be measuring directly before the air handler and directly after the air handler using the same static pressure tips. You take separate readings and then you add the two numbers together. That gives you external static pressure. Let's see, what else do we have here? Oh, here's one. So one of the comments was a user went to the Energy Ocean website and found it can be a little bit deceiving. It shows North Dakota as having no energy code, when in fact 80% of the population lives in a jurisdiction that does. This is a perfect example of finding out who your local code jurisdiction is. When I went to Colorado and I did this same kind of presentation, I decided, it was a good idea, being a good presenter, to look up what the code requirement was in the state of Colorado. That's when I found out that Colorado didn't have that 2009 or greater energy code, but in talking to the local HVAC Votech school in Teletech, who has a really strong connection with the building community in El Paso County, Colorado Springs, they had a very specific testing value for both infiltration and for duct leakage, which is not reflected in the state. So that's it. Yes, it can be deceiving to say, the state isn't at a particular value, but always check with your jurisdiction to see. So we've got a couple more questions. I'm going to see if I can get to them real quickly. One question is, depressurization test is not recommended. Is the depressurization test not recommended? The depressurization test is perfectly acceptable. Just be aware that you have to do a little bit of fine tuning of how you do the test setup. So Most people don't do a depressurization test just because it's easier, faster, and people want to, especially if you have duct leakage in an attic or a crawl space, when you depressurize, that means you're dragging all that stuff from the attic or crawl space into the house. So most people don't like to do a depressurization test, but it's certainly an acceptable test. And in some cases, that may be the only thing that you can do depending on other criteria of the house. And let's see. Talk about using the pressure pan as a diagnostic tool. Again, the pressure pan is really just a qualitative kind of test. It's not one that says this ductwork is leaking X CFM. So it's just a way to help look for disconnects and things like that. In a lot of jurisdictions, using the pressure pan test is really a great way to help speed up the process of finding leaks. So just being aware that the pressure pan is not a quantitative test, it's really a qualitative test, and you need to work with it a little bit. And I think that completes all the questions that we have today. There's going to be some more. You can still continue to ask your questions. We'll be able to answer those. Excuse me. We'll be able to answer those. Those that have asked questions, we'll be giving you that information in email. Again, this presentation will be available online very soon, and we hope that you've enjoyed it. It's been worthwhile, and we look forward to having you again in future sessions. So with that, thank you and hope you have a great day. Thank you.